Good morning, students. We are going to go through 2019 paper 2. Okay, so when we look at 2019 N-level paper 2 for question 1, you notice that for question 1, they are actually giving you some units which we have already come across quite often during our studies. Okay, so first one, charge, EMF, resistance and speed. By now, you should be able to match them accordingly. Okay, so if we match them accordingly, you should be able to obtain the following. So you should be able to obtain the following. So for coulombs, it's actually charge. For meters per second, it's actually the quantity for speed. Okay, and for ohm, is actually the quantity for resistance. Volt will then be EMF, electromotive force. Okay, so you also realize that the total marks is 3 marks here and not 4 marks. It just means that it does not give you marks if you have some answers that are wrong. For example, okay, if you have 2 out of 4 correct, you probably get at most 1 mark. Okay, so this is something that you might want to take note. Okay, there will be only partial awarding of marks if you don't get a certain number. Okay, so this I will not be able to tell exactly what is the actual value, okay, that the markers will award if you don't score all 4 correctly. So for question 2, a man uses a pulley system to lift a sack of rice. The sack of rice has a mass of 25 kg and it takes 5 seconds to lift the sack 6 meters above the ground. Okay, so we also know that G is 10 newtons per kg. Okay, in the next part of the question, okay, calculate the gravitational potential energy gained by the sack when the rice is lifted 6 meters above the ground. So we know from this question that they are looking for gravitational potential energy. Okay, so very quickly, you should be able to recall that the gravitational potential energy is actually mgh. At the same time, you notice that I have been labeling or annotating on the question itself because it helps me see where the values are. Okay, and because of that, I'm able to now substitute the values in very quickly and obtain my answer. So 25 kg multiplied by 10 newtons per kg and multiplied by the height 6 meters. Okay, this gives me the gravitational potential energy to be 1500 joules. Okay, so now we just need to complete the question by answering on the dotted line as well. Okay, for part B, calculate the power supplied by the man to lift the sack 6 meters above the ground. Now, when we look at this question, we know that power is equals to energy divided by time. And this is something that you have to remember. So now with this information, we can also link the energy back to part A, which is gravitational potential energy, because that's the only energy available in this question. So we substitute the values, 1500 joules and 5 seconds, and we will be able to obtain the value of 300 watts. Okay, so you will notice that this particular question does not have a unit at the end, so it's important for you to label the unit, otherwise you will not be able to get your marks accordingly. Okay, so let's move on to the next question. Okay, a tractor which travels over soft and sandy ground has wide tires. So there are some keywords here that you can actually tell, for example, like soft and sandy ground and wide tires. From these two, you can actually tell that it's actually related to the topic of pressure, because this is the only chapter that talks about wide things that are wide and sitting on some ground, whether it's soft or not. Okay, so from the question below, explain why the tires of the tractor need to be wide to travel over the soft and sandy ground. Okay, so I will not give you the full answer because it really depends on how you write your answers, but here are some things that we are looking out for. For you to get the first mark, you need to be able to link that the tires is somehow related to pressure. In fact, wide tires will give us low pressure because the force is distributed over the wide tires. So this makes the area in contact with the ground to be smaller. Okay, but at the same time, we also know that when there's a low pressure, it will not be able to sink into the ground easily. So this second part is actually the answer that will give you the second point. Okay, so do answer in full complete sentences and try to link back to the question clearly so that marks can be awarded. Okay, so without further ado, we'll move on to the next question. Okay, in this particular question, we are looking at the speed time graph of a train that left on the journey. Okay, so part A, describe the acceleration of the train during the first 20 seconds of the journey. So if you look back at the question itself, you notice that the first 20 seconds of the journey is over here, and from 0 to 20 seconds, the graph looks like a straight line, an inclined straight line to be exact. Okay, so this is important because it tells us that something is constant. Next, we know that this is a speed time graph. So because it's a speed time graph, it will be able to tell us a lot of information. But if you look back at the question, what do we actually want? We want to find the acceleration of the train. So let's jot down some information together, okay, so that it's easier for us to understand where we are going from here. So we know that the first 20 seconds, the graph is a straight line. And when it's a straight line, okay, we can actually say that the gradient is constant. Okay, so linking back to the question here, we are looking for acceleration. So we know that acceleration can be found from the speed time graph through the gradient of the graph. So acceleration is actually the gradient of the speed time graph. Okay, and in this first part of the question, first 20 seconds, you notice that the gradient of the straight line graph is actually constant because it is a straight line there. Okay, so once we know that it's constant for the first 20 seconds, we can now put our answer down in the question below. Okay, so looking back at the question, we are looking at gradient of the speed time graph. So we can actually calculate the gradient. Okay, so you notice that at 20 seconds, the speed is 18 meters per second. And from there, I can actually calculate the gradient, okay, to be 18 divided by 20, which will give me 0.90 meters per second squared. So I will now craft the answer. Acceleration of the acceleration of the train is constant, and this is the very basic level of answering. Okay, but I would like you to upgrade your standard. So you can actually put in, or you should actually put in the exact value at which the acceleration is at. Okay, so acceleration of the train is constant at 0.90 meters per second square for the first 20 seconds. Okay, so looking at the next part of the question, from the graph, determine what is the greatest, what time is the greatest speed. So the keyword is actually from the graph. So you actually need to refer back to the graph itself. So looking up back at the graph, okay, you notice that the highest part of the graph is somewhere around here. Okay, at around the 27, I suppose, yeah. But they didn't ask you for the maximum speed, but instead they ask you what time. So if you look carefully at these parts where the graph actually just reach the maximum, and you trace it back down, okay, you should be able to see that the timing in which it reached is actually 40 seconds. So therefore, the answer is 40 seconds. Okay, so looking at part C, okay, we see that the driver applies the brakes, okay, for the 55 seconds after leaving the station, okay, and the totally stops 22 seconds later. So we will make use of the graph again, identify the 55 seconds, where is it on the graph, okay, and we have to draw our line from there. Okay, so this is the 55 seconds. Okay, I shall draw the dotted line down for me to visualize quickly. Okay, and we know that the ending time is actually 22 seconds later. So this is where you need to be very careful, because you actually need to calculate, okay, the actual time that it stops and not just estimate that it's supposed to be 80. So the end time will be actually 55 seconds plus the 20 seconds. Sorry, just now I said wrongly. Okay, and this will give me 75 seconds. Okay, so from here, we can then go back to the graph and draw our straight line down, okay, to represent the train stopping. Okay, so please do not use freehand to draw. Use a proper ruler and draw it neatly. In this case, I did not have a ruler to draw, so I'm using freehand. This is not a good example. Okay, let's move on to the next question. Okay, we see that a sample of solid wax is gently heated for 10 minutes. The temperature of the wax is recorded every minute. The results are shown in the table. Okay, so we need to describe the structure of the solid wax at 0 minutes in terms of the arrangement of the wax molecules. So in this question, they are asking for the arrangement of the particles. Okay, arrangement of the particles, and we need to bring it to context of the wax molecules. It's not good enough to just leave it as particles. Okay, so looking back, we need to identify what is the starting state, okay, which is actually solid in this case, because this is solid wax. Okay, so we can then now craft the answer to incorporate the words wax molecules, and we know that in solid wax is always in a regular fixed arrangement. So we will now write the answer. Okay, the wax molecules are arranged in a regular and fixed position. Okay, so there is no need to mention about the movement of the particles. Okay, so you don't need to write about the vibration of the particles itself. Okay, so let's move on. Using the results, describe and explain what happens in a period of 4 minutes to 8 minutes. Okay, so you can see that from 4 minutes to 8 minutes, the temperatures are the same. Okay, so we can say that temperature remains the same. Okay, so what does temperature remains the same mean to us? In this case, temperature remaining the same means that the wax in this case is actually undergoing a change in state or change of state. Okay, so it's actually changing from one state to another. So we need to know what type of change is it. So at the start, before 4 minutes, it's actually solid. We know that it's going to change to liquid. So from solid to liquid, the change of state would be called melting. Okay, so now we are able to craft our answers and make sure we fit it back to what the question want, which is to describe from the results. Use the results to describe and explain what is happening. Okay, so we have to make mention about the results itself, which is during the 4 minutes to 8 minute mark. Okay, there is, or the temperature remains constant. Okay, so what do we do then? Now we need to link it back to melting. So this indicates that the wax is melting. Okay, so this is how you link the answer back together using the information that is already given.